What if a plane could tell you, weeks in advance, exactly which part was about to fail? Not a warning light on the runway, not an emergency landing. A prediction made days or even weeks before anything actually goes wrong. This isn't science fiction, it's happening on real aircraft right now, and it's quietly becoming one of the biggest safety revolutions in aviation history. The old way. For most of aviation history, maintenance worked one of two ways. Either you waited for something to break and fixed it, reactive maintenance, or you replaced parts on a fixed schedule, whether they needed it or not, just to be safe. Both approaches have serious downsides. Reactive maintenance means you're always one step behind, sometimes finding out about a problem mid-flight. Scheduled maintenance is safer but incredibly wasteful. You're throwing away parts that still had plenty of life left, just because the calendar said so. Airlines have spent decades looking for a better way. AI is that better way. What's actually on a plane? Modern aircraft are covered in sensors, thousands of them. They track vibration in the engines, temperature across hundreds of components, oil pressure, fuel flow, even the specific acoustic signature of moving parts. A single long-haul flight can generate terabytes of raw sensor data. For decades, this data was collected but barely used. There was simply too much of it for humans to meaningfully analyze in real time. That's exactly the kind of problem AI is built to solve. How the prediction actually works. Here's the core idea. AI models are trained on years, sometimes decades, of historical data. Recordings of how components behaved right before they failed in the past. The model learns the subtle signatures of failure, not the obvious ones, but the tiny ones. A vibration pattern that's 2% higher than normal, a temperature curve that takes a few seconds longer to stabilize than it should, a sound frequency that's shifted just slightly. None of these things would trigger a warning light. A human inspector wouldn't catch them during a routine check. But the AI has seen thousands of examples of exactly this pattern showing up right before a real failure. So it flags the part as high risk, often days or weeks in advance, long before there's any visible symptom. The different types of predictive systems. There isn't just one kind of predictive AI in aviation. There are several working together. Engine health monitoring systems track combustion, thrust, and thermal performance in real time, often streaming data mid-flight via satellite. Structural health monitoring uses embedded sensors in the airframe to detect stress fractures or fatigue in the metal, long before they'd be visible to the eye. Component-level prediction focuses on smaller parts. Landing gear, hydraulic systems, avionics, using AI to estimate remaining useful life for each individual part, rather than relying on a generic replacement schedule. Together, these systems create a constantly updated health profile for the aircraft, almost like a digital physical exam happening in real time. Real-world examples. This isn't theoretical. Rolls-Royce, one of the world's largest engine manufacturers, has built systems that stream live engine data during flights and use AI to flag anomalies before they become mechanical problems. Airlines like Delta, Lufthansa, and Air France have implemented predictive maintenance programs that have measurably reduced unscheduled maintenance events and flight delays caused by mechanical issues. Airbus has its own platform called Skywise, which pools maintenance and sensor data across hundreds of airlines to train predictive models at a massive scale. Meaning the AI isn't just learning from one airline's planes, it's learning from an enormous, shared dataset of how aircraft fail across the entire industry. Why this matters for safety? The real value here isn't just efficiency, it's safety. The vast majority of serious aviation incidents can be traced back to something small that went unnoticed until it became critical. A hairline fracture, a slowly failing sensor, a part running slightly outside its normal parameters for weeks before anyone noticed. AI is specifically good at catching exactly this kind of slow, quiet deviation. The stuff that's nearly invisible to a human, but obvious to a model that's seen millions of data points. The economic side. There's also a massive financial incentive. Unscheduled maintenance is enormously expensive. A grounded plane isn't earning money, and emergency repairs cost far more than planned ones. Industry estimates suggest predictive maintenance can reduce unscheduled downtime significantly and cut maintenance costs substantially over a fleet's lifetime. That's part of why airlines have been so quick to adopt these systems. The safety benefit and the financial benefit point in the exact same direction. The limits. What AI can't do. It's important to be honest about the limits here. AI isn't psychic and it isn't perfect. These are probabilistic predictions, not certainties. A high-risk flag means a part is statistically more likely to fail soon, not that failure is guaranteed. False positives happen. AI also can't predict truly novel failure modes it's never seen data for. It's pattern recognition, not magic. And critically, AI doesn't make the final call. Every flagged part still goes through inspection by a certified aviation engineer who decides what actually happens next. AI narrows down where to look. Humans still decide what to do about it. Where this is headed. Looking forward, these systems are only getting more capable. As more aircraft get connected with real-time data streaming, and as models get access to larger, more diverse datasets across entire fleets and airlines, predictions are getting sharper and earlier. Some newer systems are starting to move from "this part is at risk" toward "this part will likely fail in approximately this many flight hours," giving maintenance crews an even more precise window to act in. The human side. How maintenance crews use this. It's worth understanding what actually happens once the AI flags something. The prediction doesn't ground a plane by itself. It shows up as a prioritized alert in a maintenance dashboard, ranked by risk level and urgency. Ground crews can then schedule a closer inspection during the aircraft's next routine stop, instead of waiting for a scheduled overhaul months away or reacting to a failure mid-flight. This means maintenance teams are no longer just following a checklist. They're working off a constantly updated risk map of the entire fleet, letting them focus their limited time and parts inventory on the aircraft and components that actually need attention right now. None of this works without huge amounts of clean, reliable data, and that's actually one of the harder problems in the industry. Sensors can drift or fail themselves, aircraft configurations vary between models and even between individual planes of the same model. And airlines have historically been cautious about sharing maintenance data with each other for competitive reasons. Efforts like Airbus's Skywise platform exist partly to solve this, pooling anonymized data across airlines so the models have enough examples of rare failure types to actually learn from. Regulatory oversight. Aviation is one of the most heavily regulated industries in the world, and predictive maintenance AI doesn't get a free pass just because it's new technology. Regulators like the FAA and EASA still require that any AI-driven maintenance recommendation be reviewed and signed off by a certified engineer before any action is taken. The AI is treated as a decision support tool, not an autonomous authority, which means even as these systems get more accurate, there's still a human accountability layer built into every step of the process. So next time you board a flight, here's something worth thinking about. That aircraft may already know more about its own mechanical health than anyone standing on the ground. That's not something to be nervous about, and it's arguably the single biggest reason flying keeps getting safer every year, even as the number of flights keeps growing. If you want more breakdowns of the technology quietly making aviation safer, subscribe for more videos like this one. And let us know in the comments. Would you trust an AI-flagged maintenance call over a routine human inspection? Let's discuss it below.